Hello again. For this video we're going to talk about function operations and composition, and we're going to use all of our operations and probably all of our compositions based off of these two functions here. F of x is a linear 2x plus 6, and g of x is also a linear 5x minus 3. I'm going to start off with addition. You can have a problem that looks like this: f plus g of x, or it could be f of x plus g of x. And what that really means is to just take f, which is 2x plus 6. My recommendation is to put this in parentheses and add to it, because that's what we're doing. We're adding function g, which is going to be 5x minus 3. So function x, or function f plus function g. All we got to do is combine like terms here. Now this is a plus with a times 1 on the outside, so we could basically drop the parentheses. So we're going to combine our 5x and 2x, and that's going to make 7x. And 6 minus 3 is going to leave us with plus 3. So f plus g of x equals a brand new function called 7x plus 3. Now another way you could do this is with actual input values. So f plus g of, let's say we have 3. Again, that's the same thing as saying f of 3. So we're going to input 3 into f plus g and input 3 into g, and we'll end up getting 2. Let's do the f function first. So we'll have 2, and in place of x we're going to put 3 plus 6. And we're going to add, because we are adding these, function g with the input of 3, so 5 times 3 minus 3. And then we'll just do the order of operations here, and this will of course give us 6 plus this is 15 minus 3. 6 plus 6 is going to give us 12 plus 15 minus 3. This will give us 27 minus 3, and the final answer here will be 24. Now if you were to take that same 3 right here and plug it into the brand new function, which would have been f plus g of x, the brand new function. So if we were to put that 3 in place of this x plus 3, we get 7 times 3, which is 21, plus 3, which equals 24. And you can see here we would end up getting the same answer both cases. So you can do it the long way like this, or you can compose a brand new function and then input your variable, your value, which in this case would have been 3. Let's do this again, but let's do it with subtraction. So f minus g, let's do it with x, so we'll get a brand new function. And now you can see why we'll put these in parentheses. So we're going to have 2x plus 6 minus 5x minus 3. So this minus on the outside, which is really a -1, is going to change the signs of everything inside here. So you want to distribute that -1 first. So we have 2x plus 6, -1 times -5x, and -1 times -3 is positive 3. And now we combine our like terms. So 2 minus 5x is going to give us a -3x, and a 6 plus 3 is going to give us 9. So f minus g of x gives us a brand new function, and if we wanted to we could call a different name, and it's going to give us -3x plus 9. Let's let's do the same thing up here, only we'll plug in a 3. So let's ask what is f minus g of 3? Well, that's the same thing as 2 times 3 plus 6 minus 5 times 3 minus 3. 2 times 3 is 6 plus 6, and I'm going to leave the parentheses there. 5 times 3 is 15 minus 3. I'm going to do what's inside the parentheses. This of course should have had parentheses. We'll call that 12 minus, inside parentheses here we have 15 minus 3, which is going to give us 12, and 12 minus 12 is going to end up giving us 0. Now what if we'd put that 3 up here in place of this x? So what we would have had is negative 3 times 3 plus 9. Well, negative 3 times 3 is negative 9 plus 9. You can see we end up getting exactly the same output. So whether you compose a brand new function and then input, or you input the number into each individual function and then perform the calculation or the operation, in this case, which is minus between them, you'll see you get the same solution. Let's try this now with multiplication and addition, or multiplication and subtraction. So again, we have f of x is equal to 2x plus 6. G of x is equal to 5x minus 3. Let's do a multiplication. Multiplication could be f times g of x, or you could write it as fg of x. And then we'll come back and we'll put this in, the input in here. We'll use the same 3 as we did before. So make sure this is a closed circle, because when this is an open circle, this means something different. So right now this just means f times g of x, which is the same as this. So you're going to take function f, which is 2x plus 6, and times it by function g, which is 5x minus 3. And you'll see we have a binomial times a binomial, and you can get to the answer here using your traditional FOIL method. I'm going to use distribution, so 2x is going to times with the 5x minus 3, so this 2x is going to times here and here. And then plus 6 times the same 5x minus 3, so distribute, and we'll end up with 10x squared minus 6x when we distribute here. And here we'll end up with plus 30x minus 18. And then, of course, combine our like terms. So we have 10x squared minus, and actually this is going to be a plus, negative 6 plus 30 is going to give us plus 24x, and we have a minus 18. And this should be our final answer. Now we'll do the same thing with a straight up multiplication with an input. So let's suppose we have f times g of 3. That's the same thing as saying take 2 times 3 plus 6, which is function f inputting 3, and times it with function g, where we input a 3 in place of x, so 5 times 3 minus 3. All right, let's do the inside first. So 2 times 3 is going to give us 6 plus 6 here, and that's going to be times 3 times 5 is 15. It's 15 minus 3 inside there. 6 plus 6 is 12. And that's going to be times with 15 minus 3, which is going to be 12 also, and 12 times 12 is 144. Now we can check to see if our brand new function, if we did it in regular composition form, creating a brand new function instead of calculating it out, if we were to put a 3 here and here, would it also output the 144? So let's go ahead and try that. 10, we'll put a 3 squared plus 24 times 3 minus 18. And of course 3 squared is going to be 9, and 9 times 10 is going to give us 90 plus, and then we've got 24 times 3, and that's going to give us 72, and then we have a minus 18 at the end, and we'll just add these up. So 72 plus 90 is going to give us 162, and then bring down the minus 18, and if we minus 18 from that, we'll see we have 144, and you can see the answers are the same. And this would also work whether we did f times g or g times f. It doesn't matter. Multiplication is commutative and associative, whereas during the subtraction part over here, if we had changed the subtraction over here around to g minus f in that form, of course we'd have the f function, which is this one, back here inside a parentheses with the minus. So that does change the order. So now we're going to do division. So let's say we have f over g of x, and since our functions are two binomials, there's really not much we can do except express it as 2x plus 6 over 5x minus 3. There's really no way to simplify this any further. There's no common factors here. But we can go ahead and test it. F over g of 3 And another way of stating that would be f of 3 over g of 3. So we're going to input 3 for x on the top and 3 for x on the bottom, and then just simplify. So 2 times 3 is going to give us 6, plus 6. 5 times 3 is 15, minus 3. We end up with 12 over 12, which of course is just 1. And that would also probably give us the same answer, since we have 12 and 12, if we reverse the order here and put g on top and f on bottom. But most of the time we don't end up getting the same numbers like this. Okay, the next part is going to be a little bit more challenging to understand, and this is regular composition, where the output of one function becomes the input of another. So let's start with the same functions again. F of x equals 2x plus 6, and g of x equals 5x minus 3. Now the order in which we put these into the composition makes a difference. So here's what this would look like. F, and then we have that open circle, which does not mean O. This is f composed with g of x. And another way of writing that would be f of g of x. So what that's telling us is to take all of function g and put it inside of function f. So remember, g of x is the output for function g. So if we put an input here, we get an output for g. This output then becomes the new input for f. So let's go ahead and show what that looks like. So we take function f, which is this one, and we're going to leave a big old set of parentheses for where x is. So this is all of function f. So all of function f right here. This is f. And then because g comes second, all of function g goes inside where this x. So this is all the input that goes in here. So we're going to input 5x minus 3. This becomes function g. So function g, the output of this, becomes the input for f. All we got to do now is simplify that. And we're going to distribute 2 times 5. It's going to give us 10x. 2 times negative 3 is going to give us negative 6, plus 6. And combine our like terms right here, and we end up with just 10x. So f of g of x, or f composed of g of x, will just render 10 times whatever x is. Now I'm going to show that with an actual number so you can see how it really works. So let's do it this way. F of g of 3. So that's the same thing as saying f of g of 3 up here. So I'm going to input 3 into function g. I'm going to do that first. So this is first, and then function f will be second. So function g is 5 times, and in place of x we're going to put 3 minus 3, and 5 times 3 is 15 minus 3, and 15 minus 3 is going to give us 12. So g of 3 equals 12. Now 12 becomes the input for function f. So we input a 3 here, we output a 12, and that 12 now comes over here and becomes the input for function f. So function f, we take this one and we write function f with the output of 12 becoming the input of f, plus 6. 2 times 12 is 24. 24 plus 6 is 30, and that's the same thing as if we put a times 3 right here. So 3 times 10 would have given us 30. What if we reverse the order? G of f of x. So g composed of f of x. Another way of writing that would be g of f of x. And this should give us a slightly different look. And then we'll try it again with a number. So we write the outer function first, which is g, 5. And then wherever we have our x, we got to make sure we leave a big grouping symbol, because this is function g on the outside, and what we're going to put on the inside is function f. Function f is 2x plus 6, 2x plus 6. And now we're going to distribute here and here, so we're going to end up with 10x plus 30 minus 3, so 10x, and we got 30 minus 3 is going to give us 27. So g composed of f is going to give us a brand new function, which is equivalent to 10 times x plus 27. So we'll go ahead and try that with, let's try the 3 again. So g of f of 3. So this says put 3 into function f first, and whatever you get for function f, that's what you input into function g. So we're going to do function f first, and then function g second. As we get the output of f, it becomes the input of g. So function f is 2 times 3 plus 6, and then 2 times 3 is 6 plus 6, and 6 plus 6 is 12. So we're going to take this 12, and we're going to input it into g. So 5 times 12, 5 times 12 minus 3. So the output of 1 becomes the input of the next one. So 5 times 12 is going to give us 60. And then 60 minus 3 is going to give us 57. And we can check to see if that's accurate, because if we put a 3 here into our different function, this is actually creating a brand new function. We put the 3 here. 3 times 10 is 30. 30 plus 27 outputs the same 57.